Hi, my name is Victor Young.
And my name is Forrest Young.
Our project is called Computerpreter. We wish to optimize deaf accessibility through real-time American Sign Language translation. The problem right now with the 11 million deaf people in the US is that, first of all, lip reading, writing, and typing are ineffective communication methods with hearing people. There's also a lack of interpreters, and most importantly, discrimination really limits deaf people in the hearing world. So our solution is to create a Streamlit app to facilitate the communication between deaf and hearing people in an in-person conversation. We included a trained random force classifier for fingerspelling detection, a trained recurrent neural network for dynamic ASL signs detection, too. We use a recurrent neural network instead of a 2D convolutional neural network because signs have movement. They have a time aspect. And as you can see, the results of our training of our LSTM was highly accurate. The training loss went down and the model accuracy went up. Here's the demo video. Here's a deaf person.
I'm a hearing person, and today we're going to have a conversation using Computerpreter.
The deaf person would like to first use dynamic sign to communicate. As you can see, we showed the detected landmarks on the hands, face, and body. And after the deaf person signs, you can see the predicted word. And after the deaf person is fully done, we use the Open Routers API to translate the ASL into English, and you can see the text pop up in the chat box. Now, the hearing person would like to respond.
Because it's delicious and healthy. What's your favorite type of meat?
Then the hearing person clicks transcribe audio, and now we're using OpenAI's whisper model to transcribe speech to text. And now the deaf person would like to respond in fingerspelling. And here you can see the detected landmarks on the hand, but notice how fingerspelling is now continuous frames as opposed to dynamics. And after the deaf person is done, we have the fingerspelled word. And now the hearing person would like to respond.
That's really cool. Mine is steak.
We can click transcribe audio again for speech to text. And finally, both the deaf user and the hearing user can type in the chat box however they want to show some emojis or something like that. And thus, we have a successful conversation.
We envision deaf-hearing conversations to happen on the phone, for convenience. A tablet is also fine. We interviewed our high school teacher and 29-year deaf educator, Miss Tully, and she said that Computerpreter will be especially useful at cyber-traumatic events, and also for deaf people who have, for example, intellectual loss. Here are some images from our interview. We calculated that Computerpreter will save times by up to 62%, thus increasing accessibility and utility. In our Python code, we have a trained random force classifier, we have our trained LSTM, and we have Streamlit plus GitHub code to package it all into one web app. Thank you.
Thank you. Thank you.